They have a dyno at Clemson that's in a soundproof room with 1 foot walls of just wool and fiberglass are in these like metal mesh boxes.
I'm guessing by dyno you do not mean dinosaur.
Yeah. I mean dynamometer. DYNO.
I was like Jurassic Park.
It's basically a
period. I knew someone was
going to
do it.
Oh.
And you put the car on this treadmill and you have it just run and drive, and then the dyno's like, hey, this car makes this much power.
Oh, interesting. That is kind of cool.
Pretty cool. It was pretty cool.
They have like 3 of them.
And it's so loud in there because a lot of times
gets more exercise than I do.
If they bring the car in, it'll have the muffler, but if they just raw engine, it's straight out of the engine.
They also had an engine dyno.
Yeah.
There's a great picture that MC took of me just absolutely geeking out next to Max. It's like, I don't know what he's geeking out about.
Is it the one where you have like the huge smile
Max
on
is
your
the
face?
adult.
Oh my gosh.
Max
sent me
is the
so many
adult in that
pictures of
picture.
you guys.
I think the funniest part of that room was if you're in a room and you're talking to somebody like right here, somebody steps in front of you, you could feel the difference in the sound.
Yeah. Yes.
Yeah.
Oh.
You could feel like there's the way, and I'm like, I was mind blown. I mean, I know nothing about stuff like that. I was just in it like.
It was like when you went in there and you started talking, like as you're listening to the words come out of your mouth, you're like, whoa, I am way too loud right now. Yeah. Like I feel like Cardi B.
I have that experience all the time. Welcome to the Tech Trends Podcast, where we discuss the latest manufacturing, technology, research, and news. Today's episode is sponsored by Modern Machine Shop, Made in the USA podcast. I'm Ramia Lloyd, and I'm here with
Elissa Davis, the digital community specialist.
Stephen Lamarca, AMT's plus size model.
Benjamin Moses, director of senior. Steve, tell me about you went on a journey. Was it last week?
Yeah. Well, I mean, like it was last week. We've been doing a lot of travel. And last week I did a double journey. Started the week with MTForcast.
Right.
Which is our big economics trade show, conference, whatever. I want to ask Elissa, since she's here, because I didn't get to see the whole show.
Sure.
But I did get to see some of the presenters, which were very insightful. And after about the first 3, I was like, all right, I know enough about economics for the year. It's time to go back to doing my thing. But one of our colleagues, Delaney, the senior analyst over in, what are they called now? Research. Had a presentation that she was very excited about, and I think it was covering all of our survey data. Elissa, can you speak on this?
Yeah, so her and Chris Chizik, he's our head economist?
Principal
economist. Tomato. But yeah, so they gave a presentation about the different industrial surveys that we have. So we have USMTO, which is the machine tool orders. We have cutting tool, which self-explanatory, and work holding, also self-explanatory.
And our members, our audience eats that up. They love our surveys. So she was. What kind of data was she talking about?
Well, they were talking about like data they collected like over the last like couple of years and showing kind of how. They talked about like patterns in USMTO, like compared to like IMTS years, non-IMTS years, which countries have like the largest amount of purchases, like in terms of dollars. And I think they said like the Netherlands was number 1 for work holding.
That's cool.
And it's like, why? I don't know what's going on in the Netherlands, but apparently they've got a lot of work holding needs.
Sounds like something that's fun to investigate.
Yeah.
Maybe we should look into that.
I think we did podcast.
Maybe they're the next Australia.
It was like by a lot. It was by like a couple dozen $1 billion. Like it was a lot.
Wow.
Yeah.
So we have had Scandinavian countries at a couple of conferences, like their economic development groups, coming over to the U.S. and trying to figure out how to draw manufacturing into Norway, Danish countries, Netherlands. So it's kind of interesting.
Well, they're the most metal, so naturally they'd probably want to hold it.
Sweden's awesome. Their language is like heavy metal.
Good transmissions, or not transmissions. Good suspension components.
That's right. Awesome.
Thank you for that, Elissa.
Yeah, happy to help.
The other thing that I saw at MTForcast that I thought I was really hoping. So the first presenter of like, first off, I got there a day early, and I showed up at the conference like center, like the
Right.
ballroom,
Right.
at 7:30 one morning on Wednesday morning, thinking that okay, I made breakfast,
Right.
and I go there and I see Missy
Yep.
and Jamie.
Right.
And they're like, "Oh, hi! It's so great to see you." I'm
They're
like,
excited
"Yeah,
to see
where's
you."
breakfast?" And it's like, "Breakfast isn't until tomorrow." I'm like, "We don't have breakfast on the first day," and they're like, "No, today's like just the committee's meetings. Tomorrow's the first day of the conference." So I'm like, "Great, this is amazing." But you know what? Better a day early than
Sure.
a day late. Anyway,
Oh,
come Thursday morning.
Before you get to that,
Okay.
I think that's a symptom of us kind of putting off our travel plans. Because I remember a couple years ago, we were very diligent about planning. Like we had everything in like TripIt. So go here, our
Yeah.
hotel was here, our event started here. At Automate earlier this year, maybe it was last year, I got to the MGM. Oh, and I stayed at the Marriott attached to the GM in Detroit.
Yeah.
And I thought it was a massive building. So I thought I go down to the first floor. I'm like, this is one of the recommended hotels for Automate. I go down to the first floor. I was like, I'm looking for the convention center. Where's all the exhibitors? It's a mile down the street at the convention center. I'm walking around and I ask the security guard, "Hey, did I miss this thing? Where is this convention at?" He's like, "Follow the sign, sir. You have to leave the building, go down the street."
Wow.
That's such poor planning. Where it's like, I got to the city at least, and I paid for the registration, but.
Well, thank you for sharing that. I'm glad I'm not the only one who made a huge snafu like that. But on Wednesday, even though the MTForcast had not yet started, the tours
Yeah.
for MTForcast were Wednesday afternoon.
Yep.
And I finally got to go to a Feve location.
Nice.
Not that they don't want me to show up. I mean, maybe they don't, but there's Feve's locations like all over the country.
Right.
You can go into just about any of them, and they'll happily show you around and show you some of the fun stuff that they're working on that's not classified. And I've just never found found the opportunity
Right.
to line up perfectly to actually go to one. So it was fun. See, I got to meet Marco.
Yeah, he's great.
The president of Feve. Is he like the president entirely of Feve's,
I know
or
he
just
went-
the U.S. division?
The U.S. automation side of it. Because
Okay.
Feves is very diverse. So
Yeah, they're huge.
had his location in Detroit. Every committee meeting we talk about the economic sentiment of automation, and he is 99% automotive.
Yeah.
So he has a
Yeah, oh,
strong
yeah.
sense of where they're headed, and like the impact of the strike recently. Like how does that affect Marco? And we've talked about that. And it's interesting, like some of the technologies that he demonstrates. Their factory is very fascinating because they do OEM builds, but they also do retrofits. So
Yeah.
they'll bring in like another third-party equipment and blueprint it, and then modify it and give it back. to
One
them.
cool thing that they showed us that Marco showed us while we were there, the company BraunAbility. Are you guys familiar with BraunAbility? They are a company that, like, if you are a parent of a special needs child, you probably need a minivan, and most likely a minivan, or likely a minivan that needs to haul a child or person in a wheelchair. And BraunAbility is the company that retrofits these big minivans to be able to lift a wheelchair into them efficiently. Well, that work that's done on the minivan, they actually have to remove the rear subframe and modify it. And this work is typically done entirely by hand.
Okay.
Entirely done by hand. BraunAbility is partnered with Feve, and Feve's is working on a automation cell where robots will get in there with plasma cutters.
Oh, that's cool.
I think the interior of the van needs to be stripped first,
right.
but the robots will cut perfectly the subframe out, and there will be less, retrofitting and jimmying stuff into place if a precision robot is doing it.
Yep.
And he was very excited to be like, we're doing this to help them minimize the cost of these vans as much as possible.
That's cool.
Because these BraunAbility, like modified wheelchair vans, we're talking $100,000 for a $40,000 minivan.
Yeah. That's expensive.
It's a $40,000 minivan with $60,000 worth of like hardware upgrades and just manual labor that has to be done. And if they can cut down the cost of the labor part by implementing robots and getting the robots to do the precision work and doing it right, then, hopefully we're looking at something more like an $80,000, which doesn't sound like much, but it's
a lot
enough.
to a special needs family though, because like my aunt has one of those. They're nice. They're really nice vans. And they're designed to make your life easier.
Well, that's good, but like at the end of the day, it's not a luxury thing. This is something that they need, and they need to be cheaper. And Feves is working on something like that.
And I think
it was really sick. That was like the favorite thing I saw, and I saw a V10 engine block while there. So
that's rare. You don't get to see too many V10s. I do miss the days of the Viper because that was one of the hot V10s back then.
Yeah, it was. Even though it's a 90-degree V10, which I'm sorry, that's sacrilege. It should be 72 degrees.
And I do like the concept of automation. The overall value add of automation is, people always talk about saving time, but it saves time down the road too. So if you have more precise cut, more accurate, more consistent cut from precision, from automation, that saves your time down the road. So you're not constantly reworking or doing custom work downstream.
Well, Marco was really pushing the safety aspect of it.
Oh, that's true.
It's like it's not as bad for your back.
Yep.
Like it's like the wear and tear of these workers. They'll be able to theoretically work longer, like have a longer stint in their career,
right?
Because they won't be hurting as soon. And it was cool. It's one thing for us to like talk about this on a podcast like every other week, but to see it actually being done by such a massive company, that was really cool. Anyway, past the tours, finally got to go to Feves. Thursday, the show starts, and I sit in there for the first speaker. Well, actually, I'm mic running for like the first 3 speakers, and but the first speaker, an economist, excuse me, he mentions just like real quick during his presentation, he's like, and by the way, some of this stems from the work from home movement, and I don't know what it is with like half of these CEOs today, but there's a major move just strictly from executives to get staff to come back into the office, and they're delusional, they're out of their minds. Like work from home is really something that like if we want to keep the economy stable, we're going to come back to this. Like everybody might be returning to the office right now, and it might be in a little bit of a spike, but it's going to turn around. And I wanted to hear so much more about that because I know our audience.
Yeah.
80% of the people in the crowd there at MTForcast were rabidly against that.
Right.
And not a single I was let down. Not a single person raised their hand. I'm not going to do it. Nobody in their right mind that works at AMT was going to do it.
Right.
But I could almost hear Doug was standing next to me, like when that was mentioned. I could almost hear his blood boil.
I do want to hear the shift in debate because I do remember that conversation like towards the early end of COVID when events started coming up. And that came up every single conversation, every single presentation. And I do want to hear what the change in tone is related to that at events.
It was, I guess everybody was being respectful. Right. Nobody wanted to poke the bear.
Yeah. Question for you, Steve.
What's up?
Did you mention Clemson?
No, I didn't.
Do you want to talk about
I had to leave MTForcast early because I had to go to Clemson to shoot the first episode of season 4. I can't remember which season I'm on now. Season 4 of Road Tripping with Steve.
Woo, season 4.
And Clemson invited us to their Center for Automotive Research, which is like 40 minutes away from their main campus.
Yep.
But they work closely with BMW. They work closely with Honda. Yep. If you're making cars in the United States, you're working with Clemson. It was that impressive. Like they have, I think, one of the things that I remember concluding our trip to Clemson's Automotive Research Center was I knew I was going to come to this location, this facility, and see some sneak peeks on like future vehicles. I didn't know that I was going to see a sneak peek at future tools that like assembly line workers and mechanics will have available to them in the future.
That's cool.
Was not expecting that.
That's wild.
Like wireless torque wrenches. that are like power driven torque wrenches.
And that is interesting at Clemson. They have the full life cycle of automotive.
I saw my first exoskeleton. I'm sorry, I didn't mean to cut you off. I saw my first exoskeleton.
I was going to ask about that, but I wanted you to say for the video. But that's
like this
fine.
guy was wearing it. And he's like,
cool.
I can bend over and
Feel good?
I don't feel it on my back. I feel like I'm standing up straight,
Wow,
or I feel like I'm leaning on something.
that's cool.
It was sick.
We are going to see more exoskeletons. I guarantee it.
I think so. I hope so.
Let's leave it there.
Get away from her. No alien reference.
Ramia, can you tell us about today's sponsor?
Yes. Today's sponsor is Modern Machine Shop Made in the USA podcast. Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight in the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Awesome. Thanks, Ramia.
You're very welcome.
Elissa,
Yes.
I know you found a good article. Can you tell me more about this?
I did.
3D printed organs.
Yes. So
Whoa.
This is from interestingengineering.com, which should just tell you already that it's super interesting. But so MIT has created a 3D printed heart that is like a perfect replica and it's partially about, obviously, like we have like artificial hearts, we have, there's like the bovine hearts, right? All that. But this is, you can 3D print it specifically to what that person needs.
Wow.
So MIT is creating basically like the technology to 3D print a heart for organ transplant. So I didn't even know that there was a organ shortage. Because I watch a lot of like medical shows, and so I just feel like, oh, all these people are dying on these medical shows, so there must not be a shortage. That's not the case. Apparently 17 people die each day waiting for an organ transplant.
Wow.
That doesn't
Wow.
That's wild.
So it's also wild because I have my brother-in-law, one of his best friends, he has cystic fibrosis, and he got a lung transplant.
Right.
So to me, I'm like, oh, people can get organs. Like there's no shortage, but there is. So this is kind of the first step in terms of helping close that gap with technology. I mean, 3D printing in like the medical field obviously is like kind of becoming a big thing, but
Right.
if we're able to replicate human organs with 3D printing, and I know on Grey's Anatomy, Meredith Grey was trying to do that with a liver.
Oh, yeah.
So, now we're just catching up with Grey's Anatomy.
So I do like the idea. So I do remember additive in medical field. I saw a lot of that on like limb replacements.
Yeah.
So, using like the texture, so to enable like muscle attachments back to the bones, things like that, and then getting to the scaffolding to print organs, things like that. So that I do see that they progressed a long way in the past like 5 years
Right.
on additive in medical, and I do think you hit on a key word is customization, and that's where I think just like you go to the dentist office, right? They're doing 3D printing quite a bit for dental replacements now, or customization manufacturing. So being able to manufacture a tooth for you, but it's not a one tooth fits all, right? It's same with the heart, and I think that's where the acceptance will come from, is that it's not a bank of hearts that they're going to pull from. They're going to customize each single application as the patient needs.
Well, because with organ transplants, it's all waiting for a match, someone who perfectly matches you.
Right.
Exactly.
And so this would kind of eliminate that, or at least reduce, I think, significantly that need.
Yep.
And so it would just make organs more readily available to the people who need them.
Yeah.
So
When
yeah.
can they do livers?
That was on Grey's Anatomy. That was a fictional television show.
I know what problem you're trying to solve.
But I definitely I remember watching that and being like, that's really cool. And like
Yeah.
they like, you know, like they wanted to like implant, like
Yep.
they wanted to actually like put it into person. So, I mean, with the advances that we're making in 3D printing, I mean, we're 3D printing meat. I don't see
Yeah.
why we can't 3D print a heart. So.
Well, I mean, we're 3D printing it. We're not eating it.
Someone is.
And I do like the way science fiction has become a foreigner. You mentioned Grey's Anatomy. So there was a Jude Law movie that was very similar to this. He had like some liver replacement with like a mechanical machine, but it was the repo of that because he didn't pay the loan. So it's kind of a bad sci-fi movie. And then we got like Cyberpunk, the video game. That's talk
that,
about
yeah.
limb replacement and with that's the intersection of like exoskeletons and limb replacement. So, and it's back to the old Star Trek theory. Star Trek was a forerunner for a lot of interesting technology, and I like the idea of embracing sci-fi and bring that into
Forerunner or foreigner? Both.
both.
Sean and I are actually going through the next generation now. Apparently, they released like a not an edited version, but like a remastered
Oh, okay.
version to
That's
like up the special effects and graphics. The first season is a little rough,
Sure.
but
It gets better.
it does,
Yeah.
and Picard's the best.
Picard is the best. That's the number one seed. Speaking of Picard, tell me about automated visual inspection.
Oh, okay. So I've got this awesome article that I've actually been waiting for
Oh, yeah?
to come out. I'm not the best at waiting for articles because apparently it came out a month ago. Like, I saw it at the beginning of the summer, like end of spring.
Right.
Some of our friends over at Gardner Business Media had posted pictures of a shop tour that they went to.
Right.
They went to a ThyssenKrupp facility. One of ThyssenKrupp's subsidiary companies is Billstein.
I like how
Billstein.
the subsidiary is a massive corporation
Yeah.
underneath another massive corporation.
Well, ThyssenKrupp is huge. They do everything from elevators to carbon fiber motorcycle wheels.
Yeah.
I
It's
don't
crazy.
get it.
It's crazy.
But one of their subsidiaries, a huge company, Billstein, which makes OEM like plus
Right.
Suspension components. I've wanted Billstein shocks on my car for as long as I've had my car, and I was really jealous when I saw that they got to go to this facility. But anyway, Modern Machine Shop, part of Gardner Business Media, posts eliminating automotive defects per million with automated visual inspection.
That's cool.
So they're implementing the most advanced metrology harnessed by automation robots
Right.
to reduce their part defects
Yep.
per million parts to like, and it makes sense now. Like that's what was cool about that is I look at Billstein as like an enthusiast wanting like, a nice suspension, not an adjustable one. Like
Sure,
I don't
sure.
need Ohlins, and
Yeah.
I don't know what I'm doing. There was a team of engineers back at like the OEM for your car
Right.
that tuned the suspension perfectly to what it's supposed to do. You're not going to do better than that.
Right.
Billstein could because they have a team of engineers with more degrees in mechanical engineering than you've ever seen, and it would be a good company to go to for this OEM plus part. And you also look at like we're just talking about how big of a company Billstein is and how popular, how well distributed their parts. Like you can get Billstein suspension on a Ford truck.
Yeah.
You can get it on a Mazda Miata. They work with all of the major automotive manufacturers. And how do you become a OEM plus, technically aftermarket company for suspension components, a very complicated part,
Right.
and be trusted by this many different automotive manufacturers?
Seems
How
good
do you do
quality.
it?
It's good quality.
Do they
Your
still
your
make
qu- your
Mazda
QA
Miata?
QC is on point,
Yeah.
and that's what this article's talking about.
Sorry, listen.
Do they still make Mazda Miatas?
Yes, they do.
Oh.
The Mazda Miata is Mazda's Halo car.
Is it still called the Miata or MX-5?
It's called the MX-5.
Oh, okay.
Yeah,
That's
that's a
why
plot
I was
twist.
like, I don't see the Miatas on the road. I know they were like the big sports car in
Yep.
like the 90s, early 2000s.
They still are. Melissa has one.
I'm not saying
It's one
not
of the
cool.
few
I'm
cars
just-
that's still available today with a manual transmission.
Oh, that's why I picked a different one.
the most tracked vehicle around the world. Like if you go to a racetrack, you are guaranteed to see a Miata.
Well, they're sports cars, right? That's what
They are sports cars,
Yeah.
but like it's a testament to how reliable and how durable they are and how fun they are.
My brother-in-law, who has been driving a Mazda for he's on a second Mazda, so he's been driving a Mazda for like 15 years. I'll be very happy to hear that.
And it probably has a Billstein suspension.
I will ask.
It's not hard to find out. You just peek between the wheel and the wheel well, and if you see a yellow shock absorber, it's Billstein.
Cool.
So one thing that we lose track of is like metrology at the assembly level. So we talk about parts, single component manufacturing a lot in our industry, but all of that always aggregates to an assembly. And a lot of times the failure in assembly is it's missing a part, or it's missing a screw. A couple of years ago, we had a joint meeting where Ford talked about attaching visual inspection to a robotic arm to visually inspect to make sure underneath the car, like the exhaust was installed properly, the catalytic converter is there. So a lot of times when you get to assemblies, like back at Eaton, we shipped a duct assembly, 6 foot long tube with welded flanges and some flexible joints, and we shipped there and the ship weight seemed kind of high. They got to the end user and like, guys, this is a tube expander inside of your part here. This shouldn't be here. So this scenarios where the assembly of parts come down to a lot of just visual inspection, just looking at the part and are all the components there. Obviously, there is some dimensional constraints. Like we will put into a fixture and make sure it's functionally working, or we'll measure the part and things like assembly.
Right.
But a lot of times when you're putting a box together and just screwing stuff together, the inspection is, are there enough screws? So being able to visually automate that process to improve your quality, because you can drive a lot of that data back to early in the process to say, oh, we missed this thing. How do we fix that? How do we make sure that this part is always in the assembly? So that's fascinating. I really like that approach to assemblies.
I'm glad you mentioned that, because one of my very first facility tours that I went on as a younger analyst, Steve Lesnowich was there, and we were watching a demo at this shop. It was in PA. I can't remember what. I feel bad not remembering now. But the guy explaining the demo to us was like, and we can get this within, some spec, like tolerance spec, that
Right.
did not sound very impressive at all. And I was like, wait a minute, isn't the manufacturing industry supposed to be like chasing the almighty micron? Like
Right.
you're not sub-micron, like you're talking like sub-millimeter?
Yep.
That's like a joke, right? And then and Steve Lesnar was like, Steven, there's a difference between manufacturing accuracy and assembly, like
Exactly.
fabrication
Yep.
accuracy. So that was when I almost got my first slap on the wrist.
And many more slaps later, you're here.
Many more slaps later, we're still here.
Guys, I got one on the latest innovations in metal manufacturing. And I like this article from Business News this week, where a lot of it shows the trends that we've been talking about are reinforced here. And the last two I really like because it takes us basically to the next generation of where we're headed, internally looking, but also kind of driven from end users. So the first scenario is advanced 3D printing of metals. That's straightforward.
Heck yes.
We're seeing a lot of new use cases. In the tech report, we talked about an article of the submarine industrial base using additive at the repair facilities for parts that have too long of lead time.
Okay.
They're testing, they're considering non-critical parts, which I'd say on a submarine, everything's kind of critical.
Yeah. I mean, we kind of found that out this year, didn't we?
We found that the hard way.
At least not just that one, but also like China recently got one of their military subs caught in a trap that apparently they had set out for us,
Right.
the U.S., and they got stuck in there. Yeah, so
It's a problem. But they have like a deck drain plug that they printed. It's basically probably a casting where they had long lead time or couldn't find it. So I do like the advanced use cases, and I also talked about a train repair station. There's a video of them incorporating additive for like internal components like plastic pieces where the supplier is probably making 1,000 of them at a time and it's stocking and delivering it. So if they run out or if they need to quickly fill something, that type of supply chain kind of sucks.
that doesn't sound very lean.
Not lean at all, but
That doesn't sound very just in time.
but when you have platens and die making equipment, your process is a little different than doing one-part manufacturing. So I like the use cases drawing additive closer to a point of use. And the military is doing that a lot. The other one are smart factories, Industry 4.0, or what we're calling digital manufacturing. We're seeing a lot of value of pulling data, figuring out how to streamline your processes, how to get better quality out of your part, or reducing defects, and getting to an improved supply chain, to your point. If you can improve your throughput so you're more accurate in your prediction, you can lean out a lot of process. You can get your raw material, and that improves your cash flow a lot. You don't have to buy your material early. You could wait and delay that. And that's the biggest thing that I've seen end users talk about, is being able to use these processes to improve their cash flow throughout the year. So I like that a lot. And the last two I definitely want to hit on.
Yeah.
Eco-friendly material production techniques. Guys,
That sounds fun.
I'm bringing back MQL.
Yes, sir. Yes.
That's my jam.
I think we've got a bottle of champagne on the. We might have to get one.
A bottle of MQL.
Tell the listeners that might not know. Give us a crash course on minimum quantity lubrication.
Most subtractive manufacturing processes require some kind of lubricant and coolant.
That's like the fluid that they're spraying
Right.
at the part and the tool to keep the part cool, or at least the part slick,
Right.
and the tool cool.
That's the key, is maintaining a consistent temperature. For two layers, one, you want to protect the tool itself, the cutting tool. But as you're
Maximize tool life.
as you're machining the part, if the part itself is heating up, then it's growing. So now you have dimensional issues as you're growing, especially if you're holding like a thousandth of an inch.
Right.
If you measure it on machine versus once it cools down in the CMM, there could be some discrepancy. So maintaining that consistency, that's something we don't talk about too much. But you have the option of doing just flood coolant, which you've got the little nozzles, or you have through the spindle coolant. But in the end, you're just putting as much coolant as you can in that general area and hoping
just
for the
dumping
best.
it.
Right? Minimum quantity lubrication is the concept of, I know how much lubrication and coolant I need at that interface. So all I'm going to do is spray the minimum that I need at that intersection of the cutting face and the work holding part. So you go from needing 55-gallon drums of coolant that you're going to have to maintain the concentration levels, make sure it's not going arid, and all that life cycle with that, to you could probably run a CNC mill for the same time you're running a flood coolant off of like 5 gallons for the whole year of lubricant going to
using
MQL.
MQL.
Yeah.
Is MQL as effective at? I get that. I'm sure it's as effective, if not more so.
Right.
Certainly being economical, but for lubricity's sake. But is it as effective because you're only using it's going through an atomizer,
Right,
as opposed
exactly.
to being drenched.
Correct.
Is that as good for actually cooling the part? Does it work for cooling?
That gets into your cutting technique. So it's a combination of
Okay.
not just switching from flood coolant to MQL, but it's also about cutting technique and how often you're cutting that face versus cutting the whole part and things like that. So it's there's some other techniques. You can get into torque rotal cuts. That's my jam.
So man, like if somebody was shopping around for like CAM software, not like the CAM software that I complain about, but CAM software that does more of like the post processing, the toolpath optimization, which the different companies out have amazing toolpath optimization software. But I feel like if you're trying to implement MQL, that probably limits your software, because I'd imagine not all of like the toolpath software has a setting for MQL.
It's worth exploring. This is
something worth looking into.
The entire life cycle of getting to that state. So it does drive change, like how you design your CAM applications into your actual manufacturing process. So the last one I've got.
Dude, you tricked me. I didn't even see MQL on the list.
Alloy development and customization.
You wanted to surprise me.
I did.
Okay.
Mission accomplished.
Alloy development. I'm always down for here.
So we've been working with quite a few partners, and this is kind of tied to where Additive does shine a little bit. Of our process of designing materials is fairly slow because there's a lot of information that we need. So we can define like some elements and say, throw this together in a little pot, melt it down, and get a material.
Right.
But we also have to do fatigue testing, tensile test, what's the corrosion resistant capability? How
Gotta make some dog bones.
Exactly. What's the abrasion capability? Because a lot of times the applications are, you have material strength, but it's riding on a surface, right? So
I saw a lot of dog bones at Clemson.
as you should. So what we're seeing now is the ability to simulate a lot of these different testing scenarios into obviously the digital world and iterate much quicker. So getting to, instead of physically testing 10 different variations, getting to like the final 3 and then doing verification of what the test is as opposed to fundamental testing, trying to screen out. So the ability to screen to get to your final part, final couple of designs has come a long way, and we're seeing a lot of acceleration to get to a unique material. Well, and some people are concerned about that because, in retrofit times, like if I have a very unique alloy, instead of calling out, can I get to stainless 321, which you can get off the shelf,
Right.
this very specific material may have implications in the future of how, if I break this or if I need to repair it, how do I get to that? And that's where I think additive will possibly play a role in the future of, we could repair it or we could enable custom materials in the additive process.
Agreed.
So I thought it was a fun article, and
That is fun. That's
Covers
a
everything I
lot
like.
going on.
there's a lot going on there.
That's rich. Do you guys know what dog bones are?
No.
Dog bones.
Assuming you don't mean actual like.
Yeah.
No. I just
I was like, you saw
Like, yeah, I
dogs
know what a
today?
dog
and then it took a
bone
minute
is.
to like think about it. And I was
My
like,
dog loves them.
it's a piece of sample material that is manufactured in a way that actually kind of looks like a dog bone. Like on both ends, there's like a wider, flatter part to allow this machine that tests, I think, tensile strength.
Usually tensile strength.
Of your material. So you make these material samples with like these flat ends on each end of the stick, and the middle of the stick is pretty narrow. So it kind of looks like a dog bone. That's what they're lovingly referred to as. But like it clamps down in this machine that grabs your material, and the machine just starts pulling it and measuring the force that it's pulling it at, and then it gives you some like alerts. It gives you it notes some data points that are useful, in which it lets you know at what force does it start stretching, and then it lets you know if that stretching is happening exponentially, and then it eventually just pulls it until it snaps and breaks.
The foundation of every material is the stress strain curve. So basically, how far can it go and what's the stress level? So that's why it's pulling it, and it's kind of measuring the distance between the two. And that's why the center part's precisionally machined, because they know the area.
Yeah.
You know the area, you know the force, then you know the stress. So you can plot out the stress it can handle and the distance it's traveling, and that's foundational for any material.
Interesting.
Cool.
Steven, I want to mention real quick that at MTForcast, one of the people who spoke, he mentioned that the just-in-time model for manufacturing, it's going to be on its way out.
Oh, that's some drama.
It is.
So-
It's a little. I mean, I
like,
can
it's not
see why he would
sustainable.
say that.
Yeah.
We saw in COVID that it's not really the most stable. Mm-hmm. But during COVID, just in time doesn't work if there's a supply chain issue and you're relying on people globally.
Right.
Just in time does work if you're making everything in country. Then something that happens on the other side of the world doesn't affect you.
It's a
Guys,
whole other conversation about deglobalization.
It is absolutely.
I got another term for you guys. Just in time for repair. I think that's our next thing.
How would that be classified on maintenance, though? It's not reactive maintenance.
No, it's still reactive. Something breaks, you got to replace it.
Is it reactive?
It's still reactive. So you still have predictive to say, okay, this thing's going to fail. You fix it before you repair. But this is a scenario where,
So it's prescriptive?
something broke. Our arm rest broke on the train.
I should stop talking. It's time to. I should research this more.
Now to replace that, you print it and replace it right away, as opposed to trying to buy one and replace it.
Yeah,
I'll let you know who talked about it at MTForcast. You can look
that
at the
sounds really fun.
presentation.
Yeah, I want to hear more about this.
Ramia, where can more people?
Yeah,
find
where
us so-
can they find more about this?
amtonline.org/resources. Like, share, subscribe.
Bing bong.
Bye everyone.